Our students, I welcome you to another lesson of Senior 2 Physics. I am teacher Agawa Kosuma, and from what we looked about last time, our topic was pressure, and we were able to get a few things where we are able to know that pressure is force acting perpendicularly or acting normally or acting at an angle of 90 on an area of 1 meter squared. That is force acting normally per unit area. We were able to derive that the SI unit of pressure is a Newton per meter squared. But since the person who discovered all this much about pressure was called Pascal, then we can as well represent the SI unit of pressure as a Pascal. That was what we discussed in the previous lesson. Now, in this second lesson, we want to see, we have said that pressure equals force out of area. And then, of course, force comes from mass, which is mg, meaning pressure can be mass times g over area. We know it very well that force is mg. And we have studied, and we know that mass of any body is constant. It does not change even when you move from one planet to another. But the area in contact of a body can change. For example, this is a box. Let's say it has a mass of 2 kilograms. I can press it here on this surface. So the area in contact can be different if I press it like this. I'm assuming we have a surface here. And the area in contact will be different if you press it like this or like that. So therefore, this box, it has 3 chances of having the area in contact with any flat surface. That means that pressure that is exerted by any body can differ. Meaning, if the body is pressed on a very small area, then possibly we shall have a different pressure from if a body is pressed on a very large area. That's what we are talking about. That is the pressure that we are talking about. I would wish that you write this one down. Since pressure equals force out of area, this is what I talked about, that pressure is force over area, and for anybody, its mass is ever constant. Its mass is ever constant, which always gives us a constant force. But the area in contact can change, as I was showing you here, that this is our body, so you can press it on this area, or this one, or this one. So at any point, the area can be changed. But the mass, whether you press it like this, or this, or this, the mass will always be constant, hence giving us a constant force. Meaning, the pressure will always depend on the area for any constant mass. This is what we are talking about. And we are given an example that given a box of weight 48 newtons shown, we are showing it there. Determine the pressure it exerts while resting on the surfaces. Different surfaces. We are going to determine that, and I want us to do that one, and we are going to summarize our answers in a box. So our box will be, here we have a face, then we have, so we can summarize the answers for this particular question in this table. So this is the area in contact with the surface. Then for each area, we shall calculate the pressure. Then after calculating the pressure, we shall arrive at something. And after arriving at that, then we shall be good to go. Let's begin. The area in contact of face A, B, C, D. A, B, C, D. This is a rectangle. So the area is 2 meters times 3 meters. Remember the area of the rectangle. So the area equals 2 meters times 3 meters, and this one gives us 6 meters squared. We can first calculate all the areas. BCFG. BCFG. This side is the same as this side. Okay? And the same as this one. So which is 2. So that will be 4 meters times 2 meters. And this gives 8 meters squared. DCFE. DCFE. Here we are saying our box is being turned. Now if this was A, B, C, D, and maybe this one was our BCFG, then another one maybe this one can be the other one that we have. Okay? So DCFE. DCFE. From here to here is the same as this, which is 3 meters. Then from here to here is the same as this, which is 4 meters. And this gives us 12 meters squared. Let's calculate the pressure. We are saying, we are told that it has a weight of 48 newtons. The weight is the force. So the pressure here is 48 out of area 6. And this gives us 8 Newton per meter squared. The pressure here is 48 out of 8, which is 6 Newton per meter squared. And then the pressure here is 48 out of 12. And this gives 4 Newton per meter squared. There is something that I want us to get from this. I would ask you, of the 3 areas, the 6, the 8, and the 12, which one is the smallest? Please get the smallest. So, you can see the smallest area. This is the smallest of the 3. Which one is the biggest? This one is the biggest or the largest. Let's look at pressure. Of the 3, which one is the biggest, which one is the smallest? We can see that 8 is the biggest or the largest or the maximum pressure. Then the minimum, we can see this one is the minimum or the smallest. And there is something that we want to get from here. When you have the smallest area, it is giving you the largest pressure. And when you have the largest area, it is giving you the smallest pressure. What does that one mean? I would want to ask you, what does that one mean? I want you to tell me. I would expect somebody to be raising the hand even when you are there watching me on YouTube or from any video kind of stuff. I would expect you to raise your hand. You may not raise the hand. If you will maybe get me in one of our contacts there, then we can share. But I believe you are realizing that when you have the smallest area, then you have the maximum pressure, and vice versa. And when you have the largest area, then you have the minimum pressure. So what do we conclude? We can conclude and we say that maximum pressure, conclude and say that maximum pressure equals force, which we have said does not change, out of minimum area. We normally summarize that P max equals F over A min. We just already summarize with that. Okay? And minimum pressure is equivalent to force out of maximum area, i.e. P min equals F out of A max. We can have a conclusion, and actually this one will explain to us very many things. Why, if you are pierced with a needle, it is more painful than if somebody tries to pierce you. It may be a nail or something that is having a bigger area. Watch us next, you'll be able to realize that. But before, let me see what I have understood. And I want you to just do this simple activity. Just do simple activity. That's our question. That a box of mass 300 kilogram measures 6 meters by 4 meters by 3 meters. What is the greatest pressure? What is the greatest? What is the greatest pressure it can exert? What is the greatest pressure it can exert? We shall be waiting for your responses. After doing this work, feel free to send it on any of those contacts. We shall get back to you. We shall help you get more. Remember, we are saying, no matter the situation, learning must continue taking place. No matter the situation, we may be in a more lockdown than we have been in, but we are saying we are not going to allow our minds to be locked down. That is our slogan at Back Science Education Consultants. Be there. Don't forget to like, share, subscribe on our channel so that you are always notified of whatever we put there. Thank you very much. May you have a great time.